to show you one time, and only one time, how you can solve this on the calculator. You could do it all the time if you want to. Again, you have free use of your calculator. But I personally think it's a little cumbersome, and you can plug things in the calculator wrong. But if you like this method and you want to use this method, you can always use it. Just be aware, I will always do it by hand, because I actually think by hand's a little quicker. Personally, I think it's a little quicker. But I am going to show you how to use your calculator, and you may always use your calculator if you want to. Alright, so the one time I'm going to go over how to do this on the calculator. Alright, so first you have to make sure you graph it and sketch it in the calculator correctly. We'll always have it set up where the x and y are on one side of the greater than or equal to, alright, and the constant is always down there. So we'll always have a solution set like this, right? We've got x and y's on one side, and 60 and 100 are my constants on the other side. And typically when we get to applications, we will always have these where our x and y's have to be positive. We're only in the positive set. So it's above the x-axis and to the right of the y-axis. Right, which those I can't graph in, those I just have to remember. So these are something I'm just going to have to remember. Alright, how to graph it in the calculator. So remember, the first thing I have to do is graph my equations in the calculator. And so to do that, I always have to solve for y. I have to put it in the form y equals mx plus b. That's how they go into the calculator. And so there's two ways you can do it. You can solve for y and leave it in the unsimplified case, or if you're one of those people who like to simplify to the mx plus b, simplify to the mx plus b. I won't. I will just write them out this way. And so using my equations up here, so I have the first one was 10x plus 5y equals 60. And so the first thing we do is we subtract the 10x. And so we get 5y equals 60 minus 10x. So that's the c minus ax part. Right? Then we put parentheses around that, and then I'm going to divide by 5, because I got to get rid of the 5 in front of the y. And so when I go plug this into my calculator, my y1 is going to be parentheses 60 minus 10x divided by 5. And then I'm going to do a similar thing for the other one, the second one there. Right, so that was the first one. And now the second one, which was 10x plus 25y equals 100. So the first step's the same. Move the 10x over. And so I get 25y equals 100 minus 10x. And then divide by my 25. Right, so my second equation, so my y2 is going to be 100 minus 10x divided by 25. And so I'm going to go do that. I'm going to go plug those into my calculator. So that's always the first step. Solve for y. Alright, so I'm going to pop up my calculator here and I'm going to plug those in. So again, parentheses, 60 minus 10x, and parentheses, divide by 5 was the first one. And the second one was 100 minus 10x. Not apps. There we go. Divide by 25. Alright, so I am going to probably have to adjust my window a little bit. Let me see. I'm going to do a zoom standard, but I know I'm going to have to go bigger. So my zoom, I can't quite see everything. I can't see what's happening above, and I can't quite see on my edge. And I don't really need my negatives. Remember, I want to be on the positive side. So I'm probably going to adjust my window. I like to see my axis, so I'll probably go like -2. But then I'm going to go up. I'm going to do 15. Leave my scale. Again, I'll probably do -2. And we'll do 15 again. We'll see if that gives me a good graph. Right, now I can see everything, right? I can see but basically by everything I mean I want to see where they hit the axes, and I want to see where they intersect, right? And right now I can see all of that. All right, so there's a good window, and there's a picture of my lines all graphed out together. All right, now the second part of this is I have to shade. All right, you can actually kind of use this when you're solving it. This should be part 2. It's the shade. What side do I block out? And so, I actually gave myself 16s there, but I didn't. I went 15s. 15s were fine. If the inequality is a greater than case, which actually is our cases, right? Where the greater than, so both of these would have been greater than or equal to when I simplified them. which means my y values come out bigger than my function value. So I want my y values to be bigger than it. And so when it's always the greater than case, I want to be bigger. My solution set is bigger than my lines. And so I always want to shade the below. All right, what's below the line, because that's the stuff I don't want. So if it's the greater than case, you always block out the region below the line. If it's the less than case, my y values are smaller than my line, as my solutions are below the line, and so I want to get rid of the solutions that are above the line, and so I want to block out the reason. And I didn't do one of those, but that's the rule of thumb. I did both of mine were the greater than cases, right? If you go look at these, both of these are the greater than cases. All right, and your calculator would do that. Where you do this on your calculator, your graphing calculator can shade above your line. What you have to do, and I'm just going to go show you, this is sort of the explanation here, but I'm going to show you. I'm going to go here, and I'm going to go back to my y equal, and then what you do is you hit over, and you go all the way over, and you'll see that it's blinking to the left of the y1. And I want to shade below the line. I'm trying to remember right myself. And so what I'm doing right now, that's drawing a line. And so I just kind of hit enter until I get a shade below. There's a shade above, so it was above case, that's what I used. And there's a shade below. And so I'm going to go graph, and it will shade below that first line. So if I go graph, there it's shaded below the first line. And now I'm going to do the same thing for the second line. So I'm going to go back to the y equals. Now I'm going to go down to the second one. Again, I'm going to go over until I get to the left to see it's blinking to the left of the 2, and then I'm going to do the same thing. I'm going to hit enter until it's below. I don't want above. And so there it's below, and now I'm ready to graph, and it'll shade above, below both of them. And there's both the regions shaded in this case. Shaded below because I want the greater than, so I want to keep the above, and I want to get rid of the below. So remember, the shading in is this part I want to block out, the part I don't want, which I showed you here. If I get back to there. All right, so there's my, when I did it using the online graphing calculator. Same principle though. All right, so this was, the green part was my first line. The red part, so if I remember, so this red was the second line. And so that was the 10x plus 25y equals 100. That's that edge. And then the green one here, was the 10x plus the 5y equals 60. And then don't forget, what the calculator doesn't do is the greater than or equal to, x is greater than or equal to 0, and the y is greater than or equal. And remember, this means I want both my x values and my y values to be positive. And so I need to remember, because the calculator doesn't do that, I need to be, this would be the x equals 0. I want to be positive. And so I shade to the negative side to the left. So I have to include that there. And the same thing here. This would be the y equals 0. I don't want the negatives. I want to keep the positives. And so I shade this side here. I don't want this, right, on the negative side. I only want the stuff above the x-axis and to the right, not the left, the right of the y-axis. And so you have to remember that, because that's the one thing you can't really shade and graph those in on the calculator. So you just have to remember, and most of our applications do have these, so you just have to remember you want to be in the first quadrant. The positive values are in the first quadrant, above the x-axis to the right of the y-axis. And so we shade below the x-axis and shade to the left. All right, now, how do we find our points? I got a little over shading there. Well, first thing, I'm going to label them. My first point, so this open region, this is my solution, right? And we want our boundaries, right? And so the boundary would be all of my edges here. All right, this would be a boundary. This would be a boundary, and then that's a boundary. So in red, I've kind of labeled my boundaries. Wherever there's a corner, right, there's a subtle corner there, and there's a subtle corner there. When it goes through, right, two of my lines, and so this was the line x equals 0, and then the green line, which was the 10x plus 5y equals 60. This was a corner. And so I'm going to call that corner point A, that corner point B, and that corner point C. Now A is pretty easy. You can actually see that it's at 12, 0. And the same thing with C. C is easy to see. I can see that it's at, and I did the 12, 0 backwards. It should have been 0, 12, right? And this one would have been 10, 0. And then B, if I have a nice grid and I've graphed it, I can see it. It's at 5, 2. Right, but I will check it, right, by checking my points. So A, B, C. Remember, in order for it to be a corner, it has to go through two of my inequality lines. Well, A goes through the line x equals 0 and 10x plus 5y equals 60. X equals 0. 10x plus 5y equals 60, and it was the point 0, 12. And then I check to make sure it is. When I plug 0 in, I should get 12 out. So when I plug 0 in for x, right, this 0's out. So I get 0 plus 5y equals 60, divide by 5, and y does equal 12. So it does check. And you should always check to make sure, especially if you're solving using the graphing method. Alright, next one, C, is at 10, 0. That's the next one that's sort of easy to see. It goes through the corner, so it's a corner because it goes through the line y equals 0, and through the line 10x plus 25y equals 100, and then I check that it is actually at 10, 0, right? Plug in 0 for y, so 10x plus 0 equals 100, divide by 10, x equals 10, and it checks. Alright, the last one is this point. Again, my grid's fairly nice, but you won't always have nice grids. Alright, now you do have graph paper. It is available on ReggieNet that you could print off and use, but we don't always use it. We just have regular plain old sheets of paper. And so if that's the case, well, I know it's the point B is going through is where my two lines intersect, right? It's where the 10x plus 5y equals 60 intersects with the 10x plus 25y equals 100. And there's two ways to do that. So in order to get that point, I have to solve the system 10x plus 5y equals 6, 10x plus 25y equals 100. You could solve the system using any of our methods. Since we're doing it graphically, I'm going to solve the graphical system. It's where they intersect. And so I'm going to use my graphing calculator to do that since I already have a picture here, right? I want to find this point where they intersect, so that's where I go. I go second, trace, intersect, so you pick 5. And then first curve, second curve, guess. So I got to move my cursor as close as I can to that moment, and sometimes it's a little hard to see, but my cursor looks like it's pretty close, and hit enter. And as long as it stays close, I usually just hit my button 3 times, and I guess I don't need to move. And there's where it intersects at 5, 2. And that's what my guess was. And so there's my coordinates. There's my corner boundary points. And so this is an unbounded case. Actually, I missed this question. It's unbounded, right? This is open-ended. It's open, so it's unbounded, meaning there's infinitely many solutions that go out forever above and to the left, right? Forever. And so it's the unbounded case. I forgot to say that earlier. So there's an example of solving one of these graphically. Now this is the only one that I'm going to go through the calculator method and solve. If you like it, use it. If you don't, again, I think it's just as easy to solve by hand, but that's my own personal preference. So when I do these, I'll solve them by hand. You are free to use the calculator, so it's up to you. All right, I'm going to stop there.